Okay, I want to discuss this question about special relativity with you. This is a very good question to test your understanding about the special relativity, especially how to use the Lorentz transformation to solve the question. In this question, we have three observers. First is the ground station, and the second is the Amanda spaceship. And the third is the messengers moving in Amanda spaceship. And basically, they want to observe two events. The first event is the messenger stay at the rear of the Amanda spaceship. And the second event is the messenger reach the front of the Amanda spaceship. So we can set up three different coordinate systems for these three observers to describe these two events. Let me consider the ground station. We observe the first event occur at T1G and at the location of X1G. And the second event happened at T2G and X2G, which refer in the graph is this point T1G and happened at X1G. And the second event happened at T2G and X2G. And to the Amanda spaceship, they also have its own coordinate, that is T1A, X1A, and then the second event happened at T2A and X2A. So you can denote the point at here is T1A and X1A, and then it happened at the T2A and X2A. And to the messenger, we also observe the first event happened at T1M, and then this is the X1M. And the second event happened at T2M and X2M. But this coordinate, of course, is attached together with the messengers. So three of them will measure the time interval. This is TG, I call it, and then the distance between the two events is delta XG. And to the Amanda spaceship, the observer also can measure a time interval TA and then the distance XA. And to the messengers, we also can measure a time interval delta TM, and the distance between two events is delta XN. So we can use Lorentz transformation to connect these six quantities. So let us discuss the Lorentz transformation from the ground station. So if you think that the delta Tm should equal to gamma delta Tg, which is measured from the ground station, minus V mg divided c squared and delta xg. So V mg refer to the speed of the messenger relative to ground station. So also he measured the distance between these two events, should be gamma delta xg minus v mg and delta tg. Similarly, we can use Lorentz transformation to find out the relation between the Amanda measurement with the ground. This is Tg minus V, now is Ag. This is the Amanda speed relative to the ground station. So in order to differentiate the gamma factors, so I denote the gamma factor for the messengers is gamma m, and the gamma factor for the Amanda should be gamma a. So similarly, we have the space difference in Amanda. So this is gamma a and delta x a it should be measured from the ground station. So this is VAG delta TG. So now we have 1, 2, 3, and 4 equations. However, just now we list out, we have 6 parameters here. So we should find out what information we have. So now from the question, we already know the VMG is 0.95 times of the speed of light. So the corresponding gamma factors, gamma m, should be 1 minus 0.95 squared. This value is roughly 3.2. So we also know the relative speed of the Amanda to the ground station, which is 0.8 c. So the corresponding gamma factors is 1 over square root of 1 minus 0.8 squared. So this is roughly 1.67. So what else we know? We also know that delta XA, which is measured from Amanda, the distance is 1 light year. 1 light year is equal to the speed of light multiplied 1 year. Okay. The last condition is very important. It's the key to solve the equation. That is, I want to claim that the delta m xm is equal to 0. Why? So what is delta m xm? This is the distance of the two events observed by the messenger. However, to the point of messenger, it is not moving. What is moving is the Amanda spaceship. So in the messenger coordinate, we will see the front of the Amanda spaceship is moving to him. So we will think that both of the two events actually happen at the same coordinate, but at the different times. So therefore, we have a conclusion. The delta xm, which is the two events, happen at the same position in the coordinate system of the messenger. So now what we left is only Tg and Ta and delta Tm and also delta Xg are unknown. we have 4 equations and 4 unknown. So from the mathematics, we know that we should able to find out and solve this equation. Okay, now it's the mathematic problem. We just need to solve these 4 equations with the information given. So let me start from the equation 2. Because delta xm equal to 0, therefore the delta xg minus vmg delta tg must equal to 0 as well. Okay. But delta xg also our unknown, so we need to solve out the delta xg. Where we have the delta xg, from equation 4, we have delta xa equal to gamma a delta xg minus vag and delta tg. So therefore, from here I can find out delta xg should equal to delta xa divided gamma a plus vag delta tg. So I can substitute this into here. Therefore I got plus vag delta tg minus vmg delta tg. Okay, from here we should able to find out delta tg is equal to delta xa divided gamma a and divided vmg minus vag. So you substitute all the value here. So this is 1 light year, which means c divided gamma a just now. What is gamma a? Well, gamma a is 1.67. This is 0.95 minus 0.8. This is in unit of year. Okay, 4 years. Your answer is 4 years. Okay, next we want to solve the delta TA. From equation 3, the equation 3 is here. We have delta TA is equal to gamma a delta tg minus vag c square and delta xg. Yeah, I call this phi because I need delta xg. So from phi, I know that delta xg is equal to delta x is 1 light year. 1 light year, gamma is 0. Gamma a is 1.67 plus VAG 0.8 multiplied 4 year 3.8 light year. So your delta A should equal to gamma A is 1.67 and delta G we found is 4 minus the 0.8 multiplied 3.8, so you should get the 1.6 year. So finally you can calculate the delta Tm should equal to this one. The first equation is the gamma m delta Tg minus Vmg c squared. This is delta Xg as well. So it should be delta m is 3.2. Delta Tg just now we found is 4 minus this is 0.95 multiplied 3.8, so to get 1.25 years. So finally we use Lorentz transformation as found out the answer. T G is 4 years, and if you measure in Amanda space is equal to 1.6 years, and if you measure in the messengers is 1.25 years, and if you measure the distance in the ground station is equal to 3.8 light years. If you measure in Amanda, this is 1 light year, and if you measure in delta Sm, it should be equal to 0. So that is how you use the Lorentz transformation to solve this question. Next time we will use another way to solve this question again.